and we're now at 400 subscribers. Thank all of you for bringing me to this point. 400 is a big milestone. We're just 40% of the way to 1,000, so let's keep it up. But thanks for helping me reach my goal. 400 by the end of the year, and also we're getting pretty close to the end of the year. It's already day 19, and Christmas is just around the corner, so this series is going to have to end soon, but that doesn't mean I'm going to stop making videos. I'm going to continue making videos after Advent of Code is over, obviously. There's still going to be use of code and all those programming things. I'm going to try to make more videos over the break. But also 400 subscribers calls for a special video. So I might be doing an Among Us stream, maybe. Or some other game, doesn't matter. But might be doing a stream sometime for special, or I just might be making some kind of special video to celebrate 400. So, thanks to all of you for getting me this far. Alright, today we're going to be doing Advent of Code Day 19. Basically, this is a month-long challenge where every day there's a programming puzzle. Actually, there's 2 programming puzzles, all the way until Christmas to celebrate, the countdown. So, we're going to be doing Day 19, and I'm going to be solving the problem and then explaining the solutions. If you want to see the code, it's going to be in a GitHub repository, which is linked to in the description. And if you want to see a playlist of all past and future videos, that's also going to be in the description. So let's start by reading the problem. All right, day 19, monster messages. You land in an airport surrounded by dense forest. As you walk to your high-speed train, the elves at the Mythical Information Bureau contact you again. They think their satellite has collected an image of a sea monster. Okay, first of all, that sea monster is probably over here. I think that's what they're talking about. Alright. Unfortunately, the connection to the satellite is having problems, and many of the messages sent back from the satellite have been corrupted. They sent you a list of the rules valid messages should obey, and a list of received messages they've collected so far, your puzzle input. The rules for valid messages, the top part of your puzzle input, are numbered and build upon each other. For example, and then they give an example, 1, 2, just read the example. Some rules, like 3, character B, simply match a single character, in this case B. The remaining rules list the sub-rules that must be followed. For example, rule 0, 1, 2 means that to match rule 0, the text being checked must match rule 1, and the text after that part that matched rule 1 must then match rule 2. So this is kind of like regular expressions if you know that. I'll talk a bit more about that later. Some of the rules have multiple lists of sub-rules separated by a pipe. This means that at least one list of sub-rules must match. The ones that match might be different each time the rule is encountered. For example, the rule 2, 1, 3, 3, 1 means that to match rule 2, the text being checked must match rule 1 followed by rule 3, or it must match rule 3 being followed by rule 1. Fortunately, there are no loops in the rules, so the list of possible matches will be finite. Since rule 1 matches A and rule 3 matches B, rule 2 either matches AB or BA. Therefore, rule 0 matches AAB or ABA. Here's a more interesting example. And they give an example. Here, because rule 4 matches A and rule 5 matches B, rule 2 matches 2 letters that are the same, and rule 3 matches 2 letters that are different. Very interesting. Okay, and then they give more. The received messages, the bottom part of your puzzle input, need to be checked against the rules so you can determine which are valid and which are corrupted. Including the rules and the messages together, this might look like, so this is the puzzle input. Your goal is to determine the number of messages that completely match rule 0. In the above example, A, B, A, B, 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 and these 2 patterns match, but these 3 patterns do not, producing the answer 2. The whole message must match all of rule 0. There can't be extra unmatched characters in a message. How many messages completely match rule 0? Okay, so as I said before, this is kind of like regular expressions, except there's like kind of a special thing going on where there's special expressions that are included inside of other expressions. So I think our strategy is just going to be bashing it out. So I'll see you in a bit. Okay, so we got an answer, and the answer is 126. So let's see if it's right. Okay, it's too high. Okay. Well, okay, why don't we just try to debug this, and yeah, I'll be back soon. Okay, so we have arrived at our answer. The answer is 111. Oh my god. Oh my god. I didn't type the last one. Okay, we're gonna have to wait another minute. But in this minute, I suppose I could explain, or I could just wait. I'll just wait. Okay, I think it's been a minute, so let's try again. Okay, 111 That is the right answer. Okay, so let's explain part one. So I already explained that we're going to use regular expressions for this. Regular expressions, if you don't know, basically it's kind of like this rule matching thing that this problem describes, but it's a little bit more nuanced. It has a lot more rules that you can use. It can match different types of characters, not just A and B, because A and B are the only characters in this example, but it's kind of like regular expressions, so we can actually convert these into regular expressions. So there's three types of rules, right? The first one is just a plain character. We can just turn that into a regular expression of that character. If it's a series of characters without any pipes, then we can split it into a series of rules, and then for each rule we group it in parentheses so that they're one after another. And you can see this is the final regular expressions that we end up with. It's a little bit long, but that's fine. So what we need to do is for that one, then we just split it up and then group it by parentheses. If it's a if it's a rule that's split up by pipe, then we know there's only two on either side of the pipe because it's not guaranteed, but we just assume that based on what we see from our input. So we just take both sides, we convert these into regular expressions, and then we put an OR around them. And an OR is basically just putting one group in parentheses, putting a pipe, and then putting another group. In regular expressions, that means you can take either side of the pipe. So that's how we convert it into regular expressions. Now I'll delve a little deeper into the code, just a little bit, to overview how like my strategy. So to start, we import regular expressions. This is a library, Python regular expressions library. We also have a LRU cache. This basically just guarantees that we don't have to run a function twice if we have the same input, because that's a little bit, we're lazy and we only want to run a function once if it's the same input because it's going to have the same output both times. So we import this to make sure that we don't have to run a function twice. We read the input and then we store it into a list. And then we also have a dictionary or a map to keep track of which rules are which numbers. So for example, it would give, let's go to the top. It would give that 60 as a key, and then it would give this string as the value. So this is a dictionary just to keep track of all the rules. We're going to make a distinction between rules and regular expressions here because regular expressions are a thing like that everyone uses, and rules are specific to this problem. Next, we get all the rules. We just loop through the entire thing. We have to get the number that's before the colon to get what our key should be, so what number identifies this rule. And then we need to get what's after the colon to identify what the actual rule is. So if we print out rules, let's actually import pretty printing, and then we will print out the rules, just so y'all can see what this looks like. So let's do that. Okay, so we can see that the rules look like, oh shoot, no, okay, my apologies. Okay, so you can see that the rules kind of look like this. It starts from 0 and then it just indexes the rules like that. So we just turn it into a dictionary. The keys are the numbers and then the values are the rules. So that's how we turn it into a dictionary. And then we also need to keep track of regular expressions. So after we get the regular expressions, let's actually print it out. And then so y'all can see what this looks like. So the regular expressions thing looks like this. It's kind of, wait, oh yeah, wait, hang on one second. Wait, I do not understand. Oh my god, we didn't actually index it in here because we used the LRU cache. So I suppose we should do that at the end. So let's actually we didn't actually end up using that dictionary, but let's use it. Okay, so now we can actually see what it looks like, so let's print it out. This is all the regular expressions. They're kind of big, but we just have our keys as numbers, and then our regular expressions are going to be the actual regular expressions. So actually we didn't need to do that. I actually did this wrong. Hang on. So now we can actually see what's more accurate, it gives the keys as numbers, and then the rules are just regular expressions. So that makes a little bit more sense. All right, so we have this dictionary to store all the regular expressions, and then we have our final. Actually, I guess I should explain what's actually inside these functions, right? So this first function just turns a rule into a regular expression. So for example, a rule that's like 8813 or 124.7. So that would turn that into a regular expression, like fully evaluated all the way recursion down. And how we do that is, if it's first, if it's a character, if there's a quote character in there, then it's a quote, I guess, like it's a character rule. So we just turn that into a regular expression, which is just the character. And in regular expressions, if you just have a character, then it just matches that character. Otherwise, if it's if it has a pipe in it, actually that's more complicated. If it doesn't have a pipe in it, if it just has multiple parts, then we split it up into each number. So for example, 105, 105, that would turn it into, we would get the regular expressions for rule 105 by, that's this part. But first we turn it into 105, 105. And then we do this little thing over here, which just gets each rule for each of the parts. So for example, this would get the rules for 105, 105. It would turn that into regular expressions. And then we would concatenate them together using this parentheses thing. So for example, if rule 105 was the character A, then it would turn it into this string over here. It would look like A and then A. So that's what it would turn it into. That's what this line does over here. So it just joins all those regular expressions together into a new regular expression that just puts them one after another, and it matches that, which is what the problem asks us to do. Otherwise, if there's a pipe in there, then we split it up into two parts. There's the rule before the part, and then there's the rule after the part. We turn both of those into regular expressions using these lines over here, which is kind of similar to this line over here. We just turn each of the parts into a list of numbers, and then turn that list of numbers into a list of regular expressions, and then we join those regular expressions together into one big regular expression. Then we have two, and then we join those together using a pipe. In regular expressions, a pipe just means you take what's on either side of the what's on either side of the pipe, and then you can have either of those regular expressions. So that's how we convert a rule into a regular expression. We also have get regular expression given a number. So given a number, this is the rule identifier, then we can get a regular expression based on that. And then, yeah, after that, we just get the regular expression of rule 0. So we match that to each of the lines. Notice we have to use full match, not just match, because match only matches any starting, like any prefix. So it doesn't have to use all of them. We use full match to make sure it matches the entire string. If it does, then we increment our count by 1. And yeah. So we just go through all of our input and then increment by 1 every time we see a valid expression. So that's it for part 1. Hopefully that made sense. I'll put a link to regular expression resource down in the description so you can better understand that. All right. Part 2. As you look over the list of messages, you realize that your matching rules aren't quite right. To fix them, completely replace rules 82 and 11, 42, 31 with the following. This small change has a big impact. Now, the rules do contain loops, and the list of messages they could hypothetically contain is infinite. You'll need to determine how these changes affect which messages are valid. Fortunately, many of the rules are unaffected by this change. It might help to start by looking at which rules always match the same set of values and how those rules are used by the new versions of rules 8 and 11. Remember, you only need to handle the rules you have. Building a solution that could handle any hypothetical combination of rules would be significantly more difficult. Let's see what this link contains. Formal grammar. Okay, that looks pretty difficult. All right. For example, here are the rules, here are the inputs. Without updating rules 8 and 11, the rules would only match 3 messages. That. However, after updating rules 8 and 11, a total of 12 messages match. Whew. Oh my god. This is going to be significantly more difficult than part 1. So, I'm not exactly sure how to do this. They do contain loops now, which I guess just means that a rule can contain a rule inside of itself, which doesn't quite make sense to me, but I'm sure that's fine. So I'll have to think about this, and I'll be back soon. Okay, well, we got our second answer. This is probably going to be wrong. Yeah, it's too low. Oh my god. This is... Yeah, the name is Monster Messages. This is Monster Messages indeed. Okay. I'm going to go back to solving this. Okay, so got new answers, 343. Oh, come on, 22 seconds? Okay, I'll wait it out. Okay, well, probably... Oh my god, we are now done with horrendous day 19. Oh my god. Okay. Oh, okay, that was challenging. That was really challenging. I had to look on the subreddit to get some hints for this, but hopefully today will be a good video, because hopefully this will be a better explanation. So I'll explain how you do part 2. So the idea here, they already give us some hints to this. So it says, fortunately, many of the rules are unaffected by this change, which means that it implies that not many rules actually get loops. So rule 42 doesn't actually contain rule 8. I also sorted this. I sorted the list just to make it a little bit easier to find. So the ones we care about are rules 42 and rules 31. So rule 31 is going to be up here. So we can see that both rule 31 and rule 42, they don't contain any loops. So these are the only loops we're going to have. And these loops are self-referential, so they don't refer to any other rules. So what we can notice is that we'll say that rule 42 is a regular expression, and rule 31 is also a regular expression. We want to find the regular expressions for rules 8 and 11. So first up, rule 8, we're going to deal with this one, right? How do we find the regular expression for rule 8? I'm also going to assume you watched part 1, because that explains some of the code that I'm using, as well as some of my logic, so some of my functions and stuff. I know this is really inefficient, but I wanted to make this, I was too lazy, and I want to take the easy way out, right? So for rule 8, it's either rule 42 or rule 42 and then rule 8. And we notice that if it's just rule 42, then it's just rule 42, right? But if it's rule 42 and rule 8, then we need to consider that it could be 42, and then rule 8 could be 42 or 42.8. So basically what this means is it could just be 42 or 42.42 or 42.42.42. So it's rule 42 repeated as many times as necessary. So you might want to think about this for a little bit. Rule 8 just means you repeat rule 42 as many times as necessary to match the string. And how we do that in regular expressions is, first of all, we just define our function. So these are still in the same place. We don't actually need this dictionary because we don't want to cache anything anymore, because stuff is going to change. And it doesn't take too long to run anyway. It only takes a few seconds. So rule 42, we're going to write that out because it's not self-referential, or it refers to any other changing rules. So rule 42 is going to be the same. It's going to be static. And rule 31 is also going to be static. So for rule 8, it's going to be rule 42 repeated as many times as necessary. In regular expressions, this is just a plus sign after a group. So if we put a plus sign after rule 42 in parentheses, this regular expression matches any string that is rule 42 repeated any number of times. And plus means we repeat it a positive number of times. It can't be empty. If we use star instead, it would match an empty string, which we don't want. So we want it to match rule 42 plus, which matches a string that is repeated any positive number of times. Now for rule 11, this is a little bit more complicated. We have rule 42 and rule 31 at either end, and then we have rule 11 in the middle. So we might consider it could be, okay, 42, 31, that's the first option. Or it could be 42, 11, 31, which expands to 42, 42, 11, 31, 31. And if we just expand that out, eventually it's going to go to 42, 42, 42, so on, and then 31, 31, 31. But 42 and 31 have to repeat the same number of times. So rule 11 is basically just rule 42 and then rule 31, but each of those are repeated the same number of times. In regular expressions, I tried to search for this, but I didn't find any way to make them repeat the same number of times just in one expression. So I did it the lazy way, and I had rule 42 repeated n times, and then rule 31 repeated n times. Do this for every n in the range from 1 to 20, so we can have these repeat up to 20 times. And then we join those together into one huge regular expression that can have either rule 42 and rule 31 repeated one time both, two times both, three times both, and so on. So this is just a really lazy way to do it. We have all these options for all n between 1 and 20, where n is the number of times that they repeat. So now we have rules 31 and, we have rules 11 and 8. Those are turned into regular expressions. And then once we have those, these are going to get called back on by some other functions, some other regular expressions that need to include them. So that's why we don't do any caching, because it might refer back to rules 8 and 11. So at the end, we just get regular expression 0. That's going to go down the chain, refer to other ones all the way around, make a network. And eventually it's going to refer to rules 8 and 11. And those are going to be valid. And these strings are going to get huge, like really, really big, lots of characters. But at the end, it's going to work out. And yeah. So I think the key to this problem was actually to notice that these rules aren't arbitrary, right? This text over here is very important. You only need to handle the rules you have. So you only need to consider these. You don't actually need to build a solution that could handle any hypothetical combination of rules, because that'd be really, really difficult. Because you can't do the same type of analysis, and you would have to do something really, really weird. In this case, it was rule 8 just means rule 42 repeated as many times as necessary, and rule 11 means rule 42 and rule 31 at the end repeated however many times until they meet in the middle. Whew. All right, so today was by far the most challenging day, I think, for me at least. And that was good. I like a challenge. So I suppose that's it for day 19. If you want more help, you can always go to the subreddit. I will link to that in the description. You can also leave feedback, leave a comment on this video, or you can DM me on Discord. That's also an option. Yeah, that's basically it. As always, you can leave feedback in the comments or DM me on Discord. It's always helpful. And we're nearing Christmas, so we're almost done with this series. But it's been fun. And I want to get 50 stars. So hopefully this series has been helpful. As always, feel free to leave feedback. And thanks for watching. I'll see you tomorrow with day 20. Goodbye.